How are you, all of you? I am Tamaskan Taye from Federal Technical and Vocational Training Institute, Department of Electrical and Electronics Technology. I am here to teach you Electrical and Electronics Fundamentals course. In this course, we will have at least a 10 weeks video lecture series, so don't forget to follow my channel as well as the e-learning links. In today's class, we will see about a review of electromagnetic phenomena and variables, that is about charge. We will see definition of charge, types of electric charge, how can we measure electric charge, and the properties of electric charge. Next to this subtopic, we'll see about Coulomb's law. So what is charge? What is charge? What is charge? By definition, electric charge may be defined as the fundamental property of subatomic particles that give rise to the phenomena of experiencing force in the presence of electric and magnetic fields. In the presence of electric and magnetic fields. We'll see what does it mean electric and magnetic field, but in the presence of electric and magnetic field, a charged particle will experience a force. It may be either attraction or repulsion, depending on the magnitude or the whether it is positive or negative charge. These fields exert influence on a charged particles, resulting in observable effect. Observable effect. It may be attracted or repelled. This is observable effect. Observable effect. Do you remember the subatomic structures? Subatomic structures of an atom. The subatomic structure of an atom is in the central part here. In the central part have a nucleus and proton, and in the outer part it will have, we call it orbit, and it will have electrons. Electrons will revolve around this orbit. As you can see here from this structure, the positive part is related to the proton, and this neutron is neutral, whereas these electrons are negatively charged. So when we talk about the charge, we are talking about either electrons or protons of subatomic particles. Do you know the mass of electrons? The mass of electrons is 9.1094 times 10 to the power of minus 31 kilogram. Have you seen? This is very small. This is very small, very small, very small. 10 to the power of minus 31 kilogram. This is the movable part of a subatomic particle. As you have already seen here in the central part, the nucleus consists of the proton and the neutron. So this proton is static, not movable, but these electrons are movable. They will revolve around the nucleus. I mean, around the nucleus, that means on their orbit. What types of electric charge do you know? As you have already defined, it will be either positive or negative charges are there in subatomic particle. Positive charges are associated with protons, which are subatomic particles residing in the nucleus of an atom, as you have seen already in this subatomic structure. They are represented by this positive symbol. We can represent protons as this positive symbol. On the other hand, a negative charge are linked to electrons which orbit atomic nucleus and are denoted by the symbol minus. Is the symbol minus. We can represent the electrons by a nucleus. As you can see here, these are the electrons. And these are the protons. So this is a positively charged particle, subatomic particle. This is a negatively charged subatomic particle. The distinction between positive and negative charge plays a vital role in comprehending the behavior of electrically charged objects. There may be by different means the atoms or some materials in matter may be charged electrically by different means. It may be by friction, or it may be like by rubbing, or it may be by induction, or it may be by conduction. By any means, any matter, it may be charged. So opposite charges such as positive and negative, it will attract to each other. This is one property of a charged particle. They may attract to each other. If they are oppositely charged, by different means. As I told you, it is maybe by induction, or it may be by conduction, or it may be by friction. By any means, it may be charged. If they are oppositely charged, they will attract to each other. Attract to each other. Whereas positive or negative and negative similar charges, that means they will repel to each other. They will repel to each other. This fundamental principle is the foundation for various concepts of electromagnetism. Most of the applications of electromagnetism is while depends on this attraction and repulsion. This attraction and repulsion. This is the indicates the repulsion. The repulsion. As you can see here, positive and positive parts, they will repel to each other, while these opposite charges will attract to each other, as you can see from this figure. As you can see from this figure. When object carries a negative charge, it possesses an excess of electron compared to proton. As you remember from the subatomic particle structure, if an atom have these more protons on the nucleus, that means the electrons are moved by different means, we can say that this is positively charged. Positively charged. While if the number of electrons are more than that of the proton, we can say that the atoms are negatively charged. The atoms are negatively charged. Conversely, a positive charge indicates an excess of proton relative to electron. It is important to know that when an equal number of positive and negative charges are present, they cancel each other out, and the atom or that matter will have a neutral state. If the number of protons and the number of electrons are equal, they will cancel to each other, and the object will become at neutral state. At the neutral state. How can we measure electric charge? How can we measure electric charge? Coulomb is the unit of electric charge. Coulomb is the unit of electric charge. What does mean 1 coulomb? 1 coulomb is the quantity of charge transferred in 1 second. The quantity of charge transferred in 1 second. Within a short period of time, that is 1 second, how much quantity of charge is transferred in 1 second? This indicates 1 coulomb. Mathematically, we may define coulomb is represented as Q, which is equal to current times T. Current times T. Current is, as you remember, or you may not remember, but we will define in the future. Current means the flow of charge within a short period of time. That is the change in charge within a specific period of time. That means charge means current times T, where Q is the electric charge, I is the electric current, and T is the time taken to transfer the amount of charge from one point to another point. From one point to another point. What is the properties of this electric charge? We have defined what does mean electric charge, and we have seen some of the effects of charged particles on the magnetic as well as electric fields. So what properties of this electric charge are there? The first one is additivity of electric charge. Additivity of electric charge. What does mean additivity of electric charge? When charges combine, their magnitude add up algebraically. We will add up algebraically. The other term is, the other property of electric charge is conservation of electric charge. Conservation of electric charge. In an isolated system, electric charge is conserved. This means the total electric charge within a system remains constant over time, even though by different means, it may be by induction, by conduction, or by friction, from one atom to another atom, it may be transferred, but still, the isolated system, the number of electrons and protons are equal. That is, the algebraic sum of all charges present in the system remains the same, even though it is transferred by any means. This is what we call conservation of electric charge. That means electrons, the charged particles will not be created, neither destroyed. They will be conserved, like that of energy. Energy neither created nor destroyed, like that. Electric charge is conserved. Conserved. The other property of electric charge is quantization of electric charge. Electric charge comes in discrete, indivisible units called elementary charges. That is, in discrete, indivisible units called elementary charges. We call it elementary charges. So the smallest unit of electric charge is the charge carried by an electron. The charge carried by a single electron, an electron, which is approximately minus 1.6 times 10 to the power of minus 19 coulomb. This is the charge of a single electron. This quantization of charge implies that electric charge can't be divided into a smaller parts. A smaller part. This is the smallest part, what we call the charge of electrons. That is minus 1.6 times 10 to the power of minus 19 coulomb. This is some of the properties of electric charges. How can we measure the force of attraction and repulsion? As we have seen, is similar charges may be attracted, repelled, and opposite charges may be attracted to each other. But how can we measure the force of attraction and repulsion of these types of forces? We know that like charges repel each other while unlike charges attract. However, have you ever wondered about the strength of this force acting between charges? The strength of this force. The strength of this force. Have you ever wondered? Coulomb's law offers us a method to calculate this force precisely. Coulomb's law have a method to calculate this force precisely. This is the repulsion and the attraction what it indicates. This is the repulsion of similar charge and this is the attraction of opposite charge. But how much? How much? This force is it. So Coulomb's law offers us a method to calculate this force precisely. What is Coulomb's law? According to Coulomb's law, the magnitude of electrostatic force between 2-point charges is directly proportional to the product of their magnitude and inversely proportional to the square of the distance between the separating them. The square of the distance separating them. Coulomb's law have defined this law. The magnitude of the electrostatic force between the 2-point charges is directly proportional to the product of their magnitude and inversely proportional to the separation distance between the two charges. So this is Coulomb's law as it states. Coulomb's law. So if the charges Q1 and Q2 are at the same sign, the force is mutually repulsive. And the force on each charge points away from other charge. As you can see here, away from other charge. If they have similar charges, the force is away from other charge. If the charges are opposite sign, then the force is mutually attractive and the force on each charge points towards the other one. As you can see here, this negative and this positive charges are opposite to each other. The force is attractive, so towards to each other. The force is towards to each other. Having this, let's see some examples on this Coulomb's law. The first example is, what is the total charge of 75 kilogram of electrons? 75 kilogram of electrons. What is the total charge of 75 kilogram of electrons? So let's do this example together. What is the total charge of 75 kilogram of electrons? Electrons is our question. So let's solve this equation together. What is the given value? The given is, we have given a 75 kilogram of electrons are there, but we are asked to calculate the charge of this 75 kilogram of electron. So we have given that the mass of electron. The mass is 75 kilogram. What is the mass of a single electron? The mass of a single electron, if you remember, I have already defined previously. So the mass of electron is 9.10 times 10 to the power of minus 31. 10 to the power of minus 31 kilogram. So we are asked to calculate the charge of this 75 kilogram. And the other thing is, what is the charge of a single electron? the charge Q of a single electron is minus 1.6 times 10 to the power of minus 19 coulomb. So our target is to calculate here the charge of 75 kilogram of electron. The charge of 75 kilogram of electron. So how many the number of electrons are there in this 75 kilogram? First of all, let's calculate the number of electrons in this 75 kilogram of electrons. So to get the number of electrons, we can use the given mass of electron, divided by a single mass of electron, This means the given mass of electron is 75 kilogram and a single mass of electron is, as you can see, 9.1 times 10 to the power of minus 31. So this will be the number of electrons. So to calculate the charge of electron, after getting the number of electrons here, we can easily calculate the charge of this 75 kilogram electron will be, which is equal to number of electron times the charge of single electron. So we can calculate, we can solve this equation like this one. Is that clear? Let's see the numbers. We have already defined the equations. The other thing is to check the numbers. So I have solved it in my PPT. So while we are calculating, the mass of one electron is 9.1 times 10 to the power of minus 31 kilograms. So the mass 75 is given. So how many number of electrons are there? M over ME will get 8.23 times 10 to the power of 31 electron. And the charge of one electron is minus 1.60 times 10 to the power of minus 19 coulomb. So we can multiply this one by this and we will get this amount. So the total charge of a 75 kilogram electron is minus 1.32 times 10 to the power of 13 coulomb. Is that clear? If you have any doubt, you can put your question on the comment box. I will prepare another video on your doubt. Okay, let's solve another example. The other one is, what must be the distance between point charges Q1 has this 26 microcoulomb and point charge Q2 minus 47 microcoulomb for electrostatic force between them to have a magnitude of 5.70 Newton. We have given charge 1 and charge 2, the magnitude of Q1 is 26 microfarad and the next is Q2 is minus 47 microfarad for the electrostatic force between them to have 5.7. The force, what type of force is there? Is that attraction or repulsion? It is attraction because the two charges are opposites. That is Q1 and Q2 are opposite. The one is negative, the other is positive. So how can we solve? This one? Let's see. We can solve this one by, let's remove this one first of all, and I will do this one. We have given that the charge is the charge of a single electron. Q1 is 26 microfarad and Q2 is 47 microfarad, and we have given the force that is attraction force because the charges are opposite. So Q1, which is equal to 26 microcoulomb, and Q2 is minus 47 microcoulomb, and the force is attraction actually 5.7 Newton. What is the force? How can you calculate the force between the two point charges, electrostatic force? From Coulomb's law, if you remember from Coulomb's law states that the force of electrostatic force between 2 point charges is directly proportional to the product of their magnitude and inversely proportional to the square of the separation distance. So F, which is equal to K times Q1 Q2 over R square. Our target is to get R square. We have given Q1 and Q2 is already given and F is known. So let's crisscross this one. If we crisscross, the unknown is here, so if we crisscross this point, our target is, we can easily get, that means K Q1 Q2, which is equal to F R square. So let's divide both sides by F. And we will get, if we divide both sides by F and rearranging, we'll get R square, which is equal to K Q1 Q2 over K Q1 Q2 over nothing over there, because we have crisscrossed, it is 1. So what is R? R, which is equal to the square root of K Q1 Q2. And F, we will divide by F. Here it is F. I have forgotten F. So, okay, let's correct it. There is some minor mistake here. So let's rearrange it. Sorry for the inconvenience. We'll correct it. This is the equation, yes? F, which is equal to, so if we crisscross, we will get F R square, which is equal to K Q1 Q2. So let's divide by both sides by F. So R square, which is equal to K Q1 Q2 over F. So what is R? R, which is equal to the square root of K Q1 Q2 over F. We have, it is already known, Q1 is 26 microcoulomb, Q2 is negative 47 microcoulomb, and F is known already, 5.7 Newton. So if we calculate the value of R, we'll get plus or minus value, and since the separation distance will not be negative, we'll ignore the negative and we'll take the positive value. So this is the solution. Let's see the number. What it seems like. I have already done in the my note. So this is the equation, what it seems like, as I have already done. So R square means we can K Q1 Q2 divided by F. So square root of the multiplication of this, will get, we have substituted the constant value. The constant value is 8.99 times 10 to the power of 9 Newton meter square per coulomb square. So you have coulomb square here. You have coulomb, this is coulomb, so coulomb by coulomb, it will be coulomb square, and it will be cancelled. So the remaining thing is only meter square and Newton, and the Newton is here, it will be cancelled. The remaining is meter square. So while we are out from a square root, it will be meter. So the separation distance is 1.39 meter. This is all about today's class. Thank you very much for your attention. If you have any question or doubt, don't forget to put your questions on the comment box. Thank you. We will meet in the next class.